Hello everyone, my name is Allan Santosh Joseph and I am a student of BS Honors in Data Science and AI from IIT Guwahati, and this is my submission for term project 2, and today I'll be walking you through my project, an AI powered loan approval prediction system, a full stack machine learning application that predicts whether a loan application is likely to be approved or get rejected. Okay, so let's start with the problem statement first. Financial institutions receive a huge number of loan applications every day, and manually evaluating each one is slow and inconsistent. Different officers can weigh the same application differently, which leads to unequal outcomes for applications with similar profiles. So, the goal of this project was to build a machine learning system that learns from historical loan approval data, things like an applicant's income, credit history, marital status, and property area, etc., and uses that to predict whether a new application is likely to be approved or not. This isn't meant to replace a human loan officer, but to give a fast, consistent, data driven first signal that a bank or even an applicant could use. Okay, so now let me quickly go through the tools and data set before I get into the code. On the machine learning side, I use Python with pandas and NumPy for data loading, cleaning, and manipulation, Matplotlib and Seaborn for visualizing distributions and missing values, and scikit-learn for everything from pre-processing like standard scalar encoder train test split to through training and evaluating the model themselves. On the application side, I split things into two services. The backend is built with Fast API because it gives me automatic request validation through Pydantic schemas, and it's fast enough to serve predictions with very low latency. The front end is a Next.js and TypeScript application styled with Tailwind CSS, which lets me build a responsive multi-step form without a lot of boilerplate. Okay, so let me walk through the code first, focusing on the key decisions rather than every single line. Uh, First, I will show you the notebook, the EDA file, where this is the whole pipeline that was built from raw data to saved model. I started with exploratory data analysis, checking first we checked df.headfo to take the look at the data set. Then we did df.info for uh, the data types. Then we did df.describe for the statistical summary of numerical columns and a null value check that showed seven columns with missing data. For pre-processing, I made a few deliberate choices instead of just dropping rows with missing data, since that would have thrown away almost a third of dataset. For numerical columns like loan amount and loan amount term, uh, I imputed the missing data with the median, not the mean, because this columns had outliers and median is more robust to that. You can see it here. And for the categorical columns, I use mode, the most frequent category, which is the standard approach for categorical imputation. And you can see it here. Then came encoding. Since models can't work with text directly, binary categorical features like gender, uh, married, education, self-employed were mapped directly to 0 and 1, and dependence was encoded as an ordinal value 0, 1, 2, 3, since it has a natural order, and property area which has three unordered categories, rural, semi-urban, urban, was one hot encoded into two dummy columns with rural as the reference category, so the model doesn't wrongly assume an order between them. So you can see all the code here for the one hot encoding. I also applied standard scalar to the numerical features since applicant income and credit history live on completely different scales. But and this is important, I fit the scalar only in the training data uh, to avoid the leakage using the train test split by keeping the test size zero point 0.2 and random state 42. So both the train and test sets kept the same class balance. That same fitted scalar was then reused, unchanged on the test set and later on live predictions. After that, I trained and compared three models: logistic regression, decision tree, and random forest, use from scikit-learn. And I will show you the comparison numbers in a minute. The best model and the fitted scalar were then serialized with pickle into loan model.pickle and scalar.pickle, PKL. So training never has to be repeated at prediction time. So all of that code is written here, the training of the models and everything. Now the backend. In backend, this predictor.py in services loads the model, that model which we have stored in pickle and scalar exactly once. When the fast API app starts up, it never retrains or refits at request time, which keeps prediction latency low. Uh, and This preprocess.py takes the incoming request and rebuilds it into the exact same feature order and the encoding the model was trained on. This is critical because if even one column is out of order, the model will still return a prediction, just a meaningless one. And finally, the front end. In front end, this loan form component collects the applicant's detail across the four steps you saw. I will show you: personal finance, loan, and review. Keeping form state in React and validating each step before letting the user move on. On submission, it calls the backend through the typed API client in I will show you, this file. Uh, Using Axios, the JSON result that comes back is then rendered by the prediction card component. Uh, the approval gauge, risk level, and confidence, and then feature importance uh, component, which turns the model coefficients into the rank bar list. I will show you. That live version is exactly what I'm about to demo. Now let me show you the actual application running. Here is the basic landing page of the website. Uh, Here you can see how it works and some snapshots of the model that I have trained. And if we go into the credit loan section, here you can see the basic form to fill the loan application. I will show you one demo. Uh, so if I fill the form, it shows the approval probability as 79.4% and rejection as 20.61%. Below that, you can see the feature importance breakdown for this. Credit history has the by far the largest weight, followed by property area and marital status. So the system isn't just giving a yes or no, it's also showing why it reached that decision. Which was the main goal of this project. Now for the evaluation part, which is really where the model selection decision gets justified. I compared the three models on a held out test set of one approx 120 applications, like about 20% I said aside earlier during the split. Uh, I evaluated using accuracy, precision, F1 score, and recall. And later confusion matrix and a full classification report from scikit-learn. So as a result, logistic regression came out on top with like about 78% accuracy, 75% precision, and 98% recall. Uh, which is beating both decision tree and random forest, which were like accuracy 70% and 75%. Uh, that's actually a useful takeaway on its own. A more complex model doesn't automatically win, and on a data set of this size, like just 600 rows, the simpler linear model generalize better. Here is the confusion matrix for the final model. Out of 80 truly approved application, it correctly identify 79, only one false negative, which is exactly where the 98% recalls comes from. It's more conservative of the rejected class. Though out of 43 rejected applications, only 18 were correctly caught and 25 incorrectly predicted as approved. That's the main reason precision at 75%. I also looked at the feature importance from the logistic regression coefficients, which you saw earlier, credit history as the most, then property area and the marriage status, etc. So, in a lending context, that precision recall trade-off actually matters practically. High recall means the model rarely blocks a genuinely good applicant, which protects revenue and customer experience. But the lower precision on rejections mean a meaningful chunk of risky applicants are still getting approved by the model. So, in a real deployment, I wouldn't treat this as a fully automated decision. It's a best use as a first pass signal. With a human reviewer still checking the cases, the model is less confident about. To summarize the project, this project took a real machine learning pipeline from a raw, messy data all the way to deployed full stack application. And along that way, I compared the multiple models rather than assuming the most complex one would win, which turned out to matter here since the logistic regression beat random forest. The biggest learning for me was that a good model is only part of the story, keeping pre-processing consistent between the training and serving, and making the prediction explainable to the end user were just as important as the model's accuracy. For future scope, I would like to explore models like XGBoost, add a database to store prediction history, and incorporate explainable AI techniques for more detailed and per applicant explanations. Thank you for watching.